All right, so we are live on Google now. Oh, sorry, on YouTube now. Okay. Assalamu alaikum, everybody. Today's session, I added a couple more things. I know yesterday's session was kind of an overload, so I'm gonna just add um, some more stuff on top of it to go over a couple of things which may not be looking helpful for you in your current area, but eventually that will help you out. So first off is if you guys able to see my screen, we have a graduation typesetting on August 2nd, which is Sunday. So that is going to go live on our Hussaini's YouTube page. And I would suggest you all to come and join us. And there will be either one or two keynote speakers. Our Maulana is going to talk about a couple of things. And so it probably will be an hour max, right, Kamal bhai? 1 hour is the slot we have.
Yes, it's an hour short program.
So it's an hour-long program, and I would suggest you all to join that session. And I'm going to be sending this in an email as well. So that is on August 2nd, Sunday. Okay, and how you're going to connect? You'll be able to connect through our IEC Hussaini's YouTube channel. Second thing about our office hours. So if you guys are okay with it, I'm going to set up for tomorrow, 6 to 8 p.m. Chicago time. And we'll see, how much do we cover here today? And then if I get, majority of the attendance tomorrow, then we'll continue on and, finish whatever, we're going to leave, or we're going to, left off today. So let's say if you are not able to get to the lab work today, then we're going to do it tomorrow. Or if you did, let's say, some part of it, then the remainder part, we're going to do it tomorrow. So that I wanted to, complete, this whole topic, by this week. Okay. All right. So any question, whatever we covered yesterday on the IP addressing side? All right. You guys are the best bunch here. No questions there.
I have a question. Sorry, Faisal bhai.
Sure, go ahead.
I've been looking in the past, and I thought that the broadcast address was always the .255, not the 254.
In a classical class A, B, or C settings, that is 255. But in subnetting, that broadcast address changes, because since we are borrowing from either from the host bit to the network bit, or network bit to the host bit, so that's why that number changes. So in the subnetting, if I have it here, so see this, the classic, conventional networking, where we have those default class A, class B, class C. So subnet masks are 255.0.0.0, or accordingly, according to the class. But yeah, for the broadcast one, in the subnetting area, those addresses changes, and we'll see it today once we go into the lab. Okay, so we covered routable, non-routable, or reserved or private versus public IP addresses yesterday. Netting we also covered. All right, so who's that? So Ali, was that you, right? Who has the question? So you see that with the subnetting, our net mask changes. Conventional /24/16 or /8, they will have the conventional net masks, but for the subnetted ones, you see that they're ending with 252, 248, 240, whatever and whatnot.
Okay. Okay. That if it's not the 0, then yes. Okay. I got that.
Yeah, exactly. So that changes, yes.
Okay.
And the more you work on in the network area, like in this subnetting side or network planning, you can tell by these ending octet if it is /30 /25 or whatever and whatnot. It's been a while for me to doing this work. Otherwise, .240, you can tell, oh hey, what this is /27 or /28 or whatever not, or number of hosts or number of subnets and all that. So it's all about practice.
That's why I was curious about that.
Yeah. Okay. Yeah. So it's all about practice. The more you practice, the more you get the get to learn these numbers by heart. Okay. So coming next, two items which I added today and that I wanted to cover. I'll try to cover as extensively as possible. So first one is the model, like how computers communicate. Let's say if I have just go into the here. All right, so let's say I have two computers here. Let's say this is computer A and this is computer B. They are connected over the network. So how does computer A talk to computer B over the network? So it's not just that you have a simple packet that goes from computer A to computer B directly over the network. It depends what type of model is deployed on that network. There are, let's say if we start with the OSI model, there are 7 layers through which this packet traverses from that computer all the way to the physical layer. And then again, those 7 layers are configured on the computer B side as well. And that's where the packet traverses from this machine all the way and then goes up to that machine. So what are these 7 layers and what is the purpose of these layers? So we're going to look into them today. This is the model is called OSI. OSI stands for Open. I think it's Open Systems Interconnect, or I'll Google it for you guys. Anyways, so yeah, Open System Interconnect. Yes, go ahead, Ashfaq bhai.
No, that's all right. That's
okay. All right. So Open Systems Interconnect, what it does is, they give you different standards. So they came up with this as standard back in the early days, and they came up with these 7 layers, and each layer has a specific purpose. Okay. Back in our college days, we remember it, PD and TSPA. So bottom up. So P stands for physical. That's the first layer. And then on top of it, we have a data link layer, then network layer, transport, session, presentation, and application. Okay. So how is it separated out? The top 3, they are normally called the software layer. And then there is a transport layer. They call it the heart of the OSI. And then the bottom 3, they are the hardware layer. So these bottom 3 layers, they sit at a hardware of some sort. And then there is a transport layer. And then on top of it, the other 3 layers, remaining top 3 layers, they sit on the software layer. So they are, at the software layer. So physical layer is where your like network cable connects, or your media connects, or any of your signals that goes through. Normally, as an example, like your Ethernet cable that you are connecting to your computer or to your server to the other server. So that Ethernet cable that sits at the layer 1, and then on top of it, it's a data link layer. That's where your MAC addresses sit. Okay, or LLC or link control protocol, or mainly the let me just go in there. CMD, and if I just type remember ipconfig command, does it give me the MAC layer MAC address, or is it ipconfig/all?
Typo in the ipconfig.
Okay. See where is my MAC address is.
I think the business address is the MAC address.
Physical address here. Okay, so this is my MAC address. This is the MAC address of my Wi-Fi adapter here. Okay, so this MAC address, there is a significance of these. It's a hex notation, 6 different octets. I think first 3 are they define the vendor, and then the remainder is the for that network interface. Anyways, so this physical address is the MAC address that actually sits at the layer 2 or the data link layer. So first layer is there, the physical, let's say my Ethernet card or my cable that is going there. And then on top of it, whatever is the MAC address. And then that's the layer 2. And then on top of it is the network layer. So network layer for you guys, just remember your network layer is where your IP address or IP packet that passes through or resides at. So remember we did yesterday, we did look into 2 type of IP addressing or the internet protocols. One was IP version 4 and another one was IP version 6. Okay, so they reside at network layer, or they call it layer 3. Okay, and then on top of it, there's a transport layer that actually helps out for the end-to-end connection. Either it's a connection oriented or connection less. So TCP and UDP, they sit on top of it. In our next slide, I'll talk more about those layer 4 protocols. What is TCP, what is UDP? And then above the layer 4, those 3 layers, 5, 6, and 7, they are the software layers. The purpose of layer 5 is session layer. It is the interhost communication. Layer 6 is the presentation, where how your data is being presented. Either the encryption is enabled there, or like your HTTP protocol sits there and all that. And then the very top layer, that's where your application sits. Let's say I have some application XYZ which is running on my computer. That application resides at layer 7. So keep in mind this layer 7, layer 4, layer 3. These are the 3 layers which I'm going to be using in our subsequent slides. There is a load balancer where I'm going to talk about layer 7 and layer 4 or layer 3. And then on the VPC side, I'm going to talk about the network layer and the transport layer. So if you are working in an industry, let's say you are working in a network, or you are going into a network arena, or let's say you are on an outage call or on a discovery call with your teams, let's say with your network guys. So normally they talk like, hey, you know what, this is a layer 4 device, or this is a layer 3 device, this is a layer 4 packet, or layer 2. Layer 2 it normally is not in use these days. That has kind of rolled up into the like everything is going into layer 3 and layer 4. So normally your routers, like your router at your home or router in your office or in your data center, they reside at network layer or layer 3. They are called the layer 3 devices. And at times layer 3 and layer 4, they merge together, and then they call it one single device that actually, does the similar purpose for you. So your network layer is the one where your IP address resides. Okay, so this is of an importance for you guys. IPv4 and IPv6 both. And then transport layer, this layer here, that's where your TCP and UDP reside, even your ICMP. So TCP and UDP are the connection oriented and connectionless, and we'll see more down below. And then application is your layer 7. That's where your main application resides. There are some load balancers. They work at the layer 7 as well. They call it application load balancers. And we'll find out more about those load balancers. So don't worry about the lingo which I am talking about right now. So 3 layers. Keep in mind that's going to be helpful for you for the exams and for interview, or if you're going into the network arena or network area, down the road for your work related purposes. So layer 7, layer 4, layer 3. Remember those, and then they're gonna come handy down the road for you. Okay. So this is the OSI model that has 7 layers. Compared to the in contrast with OSI, Department of Defense, they said, hey, you know what, this is very cumbersome to remember all those 7 layers. They compressed it down to 4 layers, and they came up with their model. They call it DOD model, or DOD model, Department of Defense model. So Department of Defense model is what they did is, out of those 7 layers, they compressed them down to 4 layers. Okay, so the top, let's start with the bottom. So bottom 2 layers, physical and data link layer, they compress it down to network layer. They call it network. And then the layer 3, they call it internet. Layer 5, which is the transport, they call it host to host. And the remainder top 3, they compress it down and call them process or application layer. So DOT model, similar deployment, they just compress some into one layer. So they compress it down to 4 layers a total: network, internet, host to host, process or application. Okay, the purpose is similar. It's just they compress it down and minimize for us to remember those layering. Okay, before I move on, any question on this area? All right, so next one I'm going to talk about connection oriented or connectionless. Okay, this is layer 4 in the OSI model. Okay, if I go back up here, layer 4 is the transport layer. That's where the TCP and UDP reside. Okay, so what is TCP and what is UDP? This is a layer 4. So TCP, so there are there are more, but just remember 2. There are 2 major type of protocols. One is called the connection oriented, and the second is called the connectionless. Connection oriented is the one that actually requires a 3-way handshake between the client and the server, or between the 2 machines. Before it establishes the connection, it requires a 3-way handshake. Okay, once the 3-way handshake completes, that means the connection is established. Now, whatever the packet is going to flow, it will keep record of it. So it makes a 3-way handshake, the connection oriented. Okay, it validates if the message is received or not. If not, then it will resend the message. Let's say after the establishment of the connection. So whenever the next packet goes, let's say if the packet got dropped, let's say you had a network glitch or something, couple of packets got dropped, they could not make it to the destination will send, hey, you know what, I did not receive that, and then it will send the source send again, resend those packets. So there is a so it ensures that, let's say if packet 1 left source could not make, let's say packet 11 could not reaches the, from source to destination, the destination will say, hey, you know what, I did not receive packet 11. So whatever the packets it received, they will, stay there. It will resend the packet 11, and then, it will continue on the rest of the, sequence there. So connection oriented ensures that the packets are arriving at the destination. If they are not, it will, ask for the, for the resend. This connection oriented is called the TCP, or Transmission Control Protocol. You guys remember in your, not in the cloud so far we have used this, but you must have heard the term TCP/IP or TCP/IP. So TCP/IP is a sandwich of layer 4 and layer 3. TCP layer 4, IP layer 3. Then you merge them together. TCP/IP they call it. Okay. So TCP is a connection-oriented protocol. On the other hand, there is a connectionless protocol as well, where it does not go with the three-way handshake, or it does not go with the resending of those packets. So source just keeps sending the packets to a destination. Let's say source is sending like 1,000 packets a second. If the destination is receiving, let's say 100 packets, 10 packets, or all 1,000 of them, destination doesn't care if it's receiving lesser packets than whatever were sent to it. It does not ask for a retransmission. So in the UDP, the communication goes faster, but there is no guarantee that all the packets receive the destination. So the reliability is not guaranteed there. Okay. So the connectionless protocol is called UDP, or User Datagram Protocol. Okay. I'll give you an example of both. One example of each. In the UDP, as an example here, these days, we are connecting more and more with Zoom accounts, or more and more with our, let's say, WhatsApp videos with our family, or a WhatsApp call with our family, or maybe a Teams meeting with our office colleagues, right? So those applications, they normally work on UDP, where if any or bunch of packets get dropped, the message will still be conveyed. So majority of or at times you must have seen that my picture got a lag, or you somehow somewhat at times somehow miss a couple of things which I said, and then but you still let's say I said a sentence, but in that sentence maybe let's say a couple of words were missed onto it, and then but you still receive the message, right? So or my picture is somewhat lagged, and then all of a sudden you start seeing me like I was at the left hand side, and all of a sudden you see me at the right hand side, right? So this is actually going through the UDP, or at times let's say I have a lag on my laptop or on my internet router, or maybe a lag at your side, or some some glitch at your side. So you receive the instead of receiving the entire message, you might have get some somewhat some of the packets got dropped there. So UDP is an example of that. TCP, let's give you two examples. Let's say you're sending an email to someone, or let's say you're trying to log into, let's say, your Gmail account. So when you connect to Gmail, like you pull up gmail.com, it asks you for a username, your email address, and then your password. So while, let's say, you type your email address, and while you're typing your password, you send the packet, you hit the enter, and then it bunches all together and then send it to the destination. If any of the packet gets dropped in between, then probably your password will not reach there in its entirety, right? So in that case, the destination will ask for, hey, you know what, this many packets are missing. So then this server or sends a packet again to the destination, whatever that was dropped. so that, this communication, ensures that the packet validation is there. Plus, if the packets are missing, it'll resend them, to the destination. Or let's say you're sending an email and a couple of packets got dropped, the message got garbled, and could not reach to the destination, not in its entirety. So that's where so these are the ones, some of the examples of the TCP protocol that it ensures that however many packets are generated from the source side, they are received at the destination side. Okay, so connectionless is like you're talking to someone on WhatsApp. At times, let's say you're talking to someone in India or Pakistan, connection got garbled, or you were not able to hear it completely. So that communication, that does not care if the packet reaches there or not. Okay, I hope I clarified these two to you guys. Any question before I move on to the next one? Okay, just making sure that you guys are able to hear me right.
Loud and clear, person.
All right. Okay, perfect. All right, so moving on next. All right, so I'm going to start with AWS VPC. Okay. What is VPC? What is the purpose of it? And how do we utilize that? Before I log in there, let me just quickly log into the console and show you guys one thing here. All right, so I am logged into the console here. You don't need to log in here. I just want to show you guys a couple of things here. If you guys remember, when we go into EC2, and if I go in there to my security groups, remember when we set up the security group, let me just take this one up here, and we added the outbound rule here. I don't have it here in the outbound. Let me just add the inbound rule. Remember, if I add the rule here, you see that we did it for SSH and we did it for RDP, right? These two services we did initially. So if I pick SSH, it tells me that SSH is a TCP protocol, right? So SSH is a TCP. What does it mean? That SSH is a connection oriented. Okay, it runs on port 22, but it's a connection oriented one. Not sure if we have any UDP service here. Okay, but I can create a custom TCP. Let's say I wanted to pick, let's say port 9909, for example, or I can create a custom UDP. Okay, so whatever the port number is, we can pick here. There's a third type here is ICMP. The purpose of ICMP is, what ICMP does is, ICMP is used to validate a connection or a communication between the two devices. So normally ping, if you guys, let me just do it here. Let's say I have two servers here. I want to validate if the server A is able to talk to server B. So the basic test we perform is we run the command ping, and then we give the IP address or the host name of this machine B here. So what it does is it actually sends, machine A sends ICMP packet to machine B, and then machine B responds back either I'm alive. Machine B responds back that yes, I'm alive. If the packet does not reach machine A within a certain time period, you will get the timeout error message. Okay, let's say if let me just clear here. Let's say if I just type ping, I'm not sure if Google has enabled ping or not. Google.com. So it is. How my router is, I think it switch over to IPv6. Anyways, all right. So I am pinging. I am sending in I am sending an ICMP packet to google.com and see if that Google is responding back, or is google.com alive or not, right? So, so I pinged the google.com, it translated into IPv6, and then it's saying the reply from this machine, the time it took is 28 milliseconds. So one packet round trip time is 28 milliseconds. Packet left my machine, reaches Google, got back to me within 28 milliseconds. Okay. So I sent only 2 packets and then I cancel it. So statistics, I am seeing that it sent 2 packets, received 2 packets, 0% packet loss. Okay. Approximate round trip time is 28 milliseconds here. Okay. So this is how we test, from one machine to another machine. And this actually goes through ICMP. Okay. There is another service, built-in service in Linux, in Windows. It's called Trace RT. Okay. That actually traces that between my machine and the other machine or other server, how many hops do I have? Okay. So trace RT is the command in Windows, and in Linux and Mac, the command is trace route. Okay. So you type trace RT. Let's say if I just type google.com. Okay. I probably will have, a lot of packets, filtered out here. So what it does is it's going to go over maximum 30 hops. So it goes up to 30 hops, and if it did not, find that answer, or that machine is beyond 30 hops, then it will give me timeout error. Oh man, this IPv6 thing. Okay.
You can try, sorry, Faisal bhai, you can try Yahoo. Yahoo gives you the IP4.
Okay, I can try that, but I doubt that it will be. So let's just see yahoo.com, because my actually router is going through this IPv6 path. Anyways, so you see that. Let me just cancel it out here. I just want to show you guys. I'm sorry. Did I close that? Oh, sorry.
AT&T is getting ready for 5G. That's forcing.
Okay, so what's happening is, I'm sorry, not ping. So I ran the trace route, and it will tell me, it is telling me that my, from my machine here to the Google's first available server, it's residing at the 15th hop. So I have to jump like 15 different router switches, firewall appliances, whatever and whatnot to get to google.com server. Okay. Like where the google.com is currently hosted at. Okay. So you just, get this information, using this command trace RT, and in like I said, in Linux and Mac machines, the command is trace route, one word, trace route. Okay. Alrighty. So coming back in here, where is the slide? Okay. AWS VPC. VPC stands for Virtual Private Cloud. Okay. Before I start on it, there's one thing which I wanted to share it with you guys. Come on. Paste it in the chat as well. All right, so this is there was a progress actually. So what happened is there's a type of computing, they call it quantum computing, and along the same line there's a thing called quantum internet. So state of Illinois, along with Fermilab, and there's one more lab, plus a couple of Illinois based universities. So they announced a blueprint today for the quantum internet. This will be the first one in US, and the distance is 52 miles between the between the two labs, and they're going to be using quantum computing and quantum area there. So for those of you who are interested in the bleeding edge of technology, quantum computing is picking up pace. It is very, very niche at this time, and then quantum internet is another part of that. So so I just pasted on the chat. So you might want to look into quantum computing and quantum internet. Google has one quantum computer or quantum computer. That is very expensive machine these days. I think it's over $100 million, and the performance is let's put it this way. I was reading one of the papers. Google is claiming that their quantum computer is 100 million times faster than the fastest computer or fastest conventional computer currently available in the market. It's 100 million times faster than that. So you do the math. It may not be mainstream for the next 3, 4, 5 years, but eventually it will be. So our current computers, they work on a principle of binaries. So the bit is either 0 or 1. Okay. But in the quantum, it's beyond that. So quantum actually, what happened is it actually based on the principles of quantum physics, and so it has atomic level, and then photons, and all sorts of crazy things out there. Current computers, they work on bits, either the bit value is 0 or 1, but that actually works, or the quantum computer works on quantum bits, or they call it qubits. So you might want to look into that. It's very, very interesting. And those of us who have their kids in high school going into the college, or their kids in the college, or those who are interested in this area, I would suggest look into that. Put your kids into it. This is literally a bleeding edge technology these days. The country which is on top of quantum computing these days is not America. Canada is is number 1 these days in the quantum computing side, and we are kind of behind. Like US is kind of behind in that. So I would suggest put your kids into it, put yourself into it. Whatever the type of opportunity you get, please go explore that. And just to give you guys a teaser here, we have one person in our community. He's doing PhD in quantum computing, and hopefully soon as the Muharram is over, we're gonna be offering a course in in that side. So you might want to look into your into the emails. Okay, we're still working on on the course outline and all that. Okay, all right. So it's kind of a sidetrack item here. Alrighty, and this thing actually popped up on my news feed today, and I was kind of happy to see name of Illinois and name of Chicago there, that we have made a leap there. Right. So okay, alrighty. So the question about the where do you so for the class sign up, so we have not finalized that yet. So soon we have all those logistics finalized. The flyer, once we have the flyer, so that will be available on our Hosseini website. Plus all you guys like all those 200 people who are in my list of this class. So once I have the flyer, I'll send out to you guys. So and then you can expand that into your circle as well. Alrighty, AWS VPC. So if I scroll down here, okay. Let's take a 5 minutes break because once I start on this, I'm gonna finish this off. So right now it's 6:50. Let's reconvene at 6:55, and I'm gonna open the floor for any questions that you guys may have.
Faisal bhai, quick question before we go for the break. After we come back, are we doing any lab work?
So I'm gonna go over this entire theory. I have about some 10 slides. I'm gonna finish those 10 slides. The plan is to do at least one lab today. Okay? Yeah.
The reason I was asking is, to make sure we have instances launched in place before we get on that part.
You don't have to launch an instance today. So it's just on, yeah.
Sure. Thank you.
Sure. Righty. So I'm gonna take a quick break as well. I'll be back probably in 2 minutes. Okay. I'm gonna mute myself. Alrighty, I'm back here. Okay, one thing I forgot to mention about this. On the right-hand side, do you see that this is the TCP three-way handshake? There's a client and then there's a server. So client sent this SYN packet. It gave the sequence number 100. The server received the SYN, server sent the acknowledgement as 101 and asked for sequence 200. Then client sent again the third packet with the sequence and acknowledgement of that. So once these three packets reaches the client and the server, the three-way handshake completes. And then once it's complete, the connection is established between the two machines. And there's a very common tool. The tool is called Wireshark. So it's freely available. You can download to your machine, and you can play around with it. Let's say if I just pick my Wi-Fi here, and you see that lots and lots of packets are coming. Let's say if I just pick TCP port 800, and let's say if I reach out to some unsecure site, unsecure website here. Let's say if I'm able to pull any site in here, I am searching for this unsecure. There is a list of let's see if this site is unsecure. No, this is secure as well. It is running HTTPS. Okay, this is not the one. Anyways, it's running on HTTP. There's a list of sites here. Okay. Not sure if you guys are able to see it here. So whenever we go to google.com, you see there's a padlock on the top left side here before the site address. If the padlock is closed, that means the site is using HTTPS or using the secure connection. And if I just click on it, saying that certificate is valid, and so it is using the HTTPS connection. So I am looking for a site that is saying either non-secure, or on some browser, you see that padlock is shown as the open padlock. Okay, so you see that this site is unlocked here. So your connection to this site is not secure. So this site is not secure. So what I am trying to do is I have enabled my Wireshark to read for this transmission here. Come on, and I stop it here. So let me just search here. Let me just remove the UDP. I'll just look for TCP. Okay, so you see that if I go back to my slide here, you see that packet sequence is going SYN, ACK, and then ACK. You see the SYN, ACK, and then ACK. So here you see the SYN packets are going from my machine. This is the IP address of my machine, and destination is this machine using this protocol. So it's going SYN packet, and then there's a SYN ACK packet, and there's an ACK packet. There's a HTTP. So if I just click on HTTP, let me just. So you see that HTTP, I see the content, whatever, because this is a non-secure one. So I can see the content here. If I just click on it, so the entire content, I can, read through it, like whatever, the content or whatever the packet are being transferred to my browser. Okay. But when we go and let's say if you just remove it here, and if I see, let's say, this TLS, it is a secure one. So you see that I see the garbage here. So that means that the packets that are being transferred, I cannot read those packets, whatever the content is, it's saying encrypted data. So SSH, like the PuTTY session that we communicate, from our machine or from our PuTTY session, or sorry, PuTTY application to our Linux instances. So that is a secure session as well. Same goes with RDP. Our SSH is a secure one. So if I able to sniff through all these packets, I will not be able to decipher it, because everything that is being shown will be an encrypted data. So since I do not have the decryption key on my Wireshark, so I will not be able to find out what the packet is is talking about. Okay, so this is how you sniff the packet on the network. Since my machine is sitting, my Wireshark is sitting on the network where my laptop is sitting at, so I can sniff through this pack through this tool. Very handy tool, normally used for although you can use it for for a malicious purpose as well, but normally this tool is being used by the network guys. Let's say they wanted to see how the packets are flowing through from one machine to another. Let's say if they wanted to go into into an advanced troubleshooting with you guys, and then you can look into it, hey, what is happening and why we are either why the packet is not making through, or the packet going, are they secure enough or not. So you can look into that into that area. Okay, alrighty. So there's just one small nugget on the Wireshark area. So I can just simply put the name here of that tool. So whenever you get time, try to play around with this. For those who are interested in going to the network side, or even if you are on the sysadmin side, just tinker around with this tool, and so that you can put this tool into your resume that I have an experience on the in Wireshark, which is a packet sniffer. Okay, all right, coming back to VPC. Kind of big topic. VPC stands for Virtual Private Cloud. So what Amazon does is they offer you inside your AWS account a VPC that is a network boundary of your account. Okay, and then all your infrastructure, all your application, all your appliances and everything that actually resides within that boundary. So VPC in a virtual private cloud, it is similar as what you have in your data center, that you have a certain boundary, like certain IP address boundary or IP subnet there, that is secured by the firewall, that's secured by or communication is going through certain routers and certain switches. So here in our case, the VPC is the outer boundary. VPC is the outer boundary of your AWS infrastructure. So whenever I log into my AWS console, I see VPC in each specific availability zone. Okay, so that VPC engulfs around my entire infrastructure, and within that VPC, my security group, my NACLs, route table, routers, my instances, security group, and everything, they reside within that. So VPC actually defines the boundary of my account. So underneath the VPC, we have subnets. And then underneath those subnets, we have our EC2 instances. And underneath those EC2 instances, we have our applications running. Okay. Although underneath those subnets, if I just go in there, we have our NACL or network ACL. And underneath those, we have our security groups or groups. And then we have our EC2 instances or our applications underneath it. So VPC is the outer boundary. Underneath it, we have our multiple subnets. And then each subnet has its own NACL or network access control list. Underneath it is a security group, which we have done quite a lot of work on the security group side. And then your instances, and then if you have any application running there. Okay. So your AWS account, okay, and then like the outer boundary, and then you have your VPC. Your VPC has the capability to have the elastic load balancer that load balances your application, or that could load balance your innermost layer. And then inside that you have your availability zone, these dotted lines. Within those availability zones, you create multiple subnets, and each subnet has its own specific purpose. If I go into so a classic 3-tier application architecture is you have your web layer, and then you have your app layer, and then your data layer. Okay, so how it goes is your web layer is exposed to the internet. So whoever is connecting through the internet, they connect to your web layer. That's where your web servers reside in. So web layer is your topmost layer. That's where your web server resides in. As an example, you type in amazon.com. So whatever the page renders to you, that is coming from the web server or the web layer. So your web layer is the topmost layer that is exposed to the outside world. So how it goes is you put your web layer in the public subnet. Okay. The bottom 2 layers that you have, you put them in your private subnet. So what happened is, so this is public subnet. Okay. What happens is this web layer is exposed to the outside world. None of your infrastructure, none of your app layer, none of your data layer is exposed to the outside world. Okay. Although web layer has the capability, you provide the capability for web layer to talk to the application layer, but web layer does not talk directly to the data layer. Okay. Your web layer talks to the app layer, and then app layer talks to the data layer. Okay. So let's say you have your, let's say, node framework running or some business logic running. So web layer, it renders the web page, and then let's say somebody type in, let's say I went to amazon.com, I type in for something, let's say I type in for let's say some XYZ product. So that query which I put into the search, it goes to the application layer. Application layer goes to the data layer. Data layer is where my database resides in. Okay. Database resides in the data layer, and that should be the innermost, secure most layer. You should not grant access to any other layer to the data layer except your application layer. And then the application layer, the best practice is it has to reside within the private subnet, not in the public subnet. So that this way, let's say if my public layer or public subnet is compromised, it's only my web layer that is going to, I'm sorry, that is going to be compromised. But my remainder of my layers, they are still in the private layer and they are secured. So only thing that is compromised is my web layer. My web servers are compromised, but still I have my data intact. My applications are intact. Okay. So classical 3-tier architecture, web layer talks to your application layer, and then it puts the request to the application layer. Then application layer goes to the database, queries the database, gets the data, massages it, and then sends it to the web layer. And then web layer, it actually renders it as a, maybe an HTML file or JS file or whatever file, and you see the results there. Let's just take as an example. Let's say if I go to Amazon.com. All right, so I went to Amazon.com and let's say I search, what do I search? Let's say I search for tires. Okay. So what happened here? I went to the web layer. In the search box here, I searched for tires. So that request went to the app layer went to the database, search for whatever the content or whatever the data we have in the database by the name tires. It sends back the database sends back the data to the application layer massages it, sends it to the web layer, and then web layer rendered it as a web server, as an HTML file to me on the onto the web server for me. So all these results, they are actually, although it is showing that it is coming directly from the web layer, but no, it is not. It has gone through at least 2-layer. If Amazon has a classical 3-tier architecture, set up there. Okay, so this is how it goes, in a 3-tier architecture. Now, if I go in here, come on, what happened? Okay, so if I go in here, although this is not a complete example, it's a 2-layer architecture that they're just not showing here. But like I said, in a 3-tier architecture, which is the classical one, your web layer, then your application layer, and then your data layer. Okay. No, and Kazmi asked the question, does it mean that the Amazon data layer is a public subnet? No, it is not. This is just an example I picked from the internet. So people may have, set it up as a 2-layer architecture. Like this one is their web layer, and then this one is there. Let me just copy this into the. So what they did is they came up with a 2-tier architecture. And in this 2-tier architecture, this is their, I'm sorry, come on. Can't I not do this? Okay, so in this here, they have one availability zone here. You see this? Inside that AZ, what they have is they have 2 subnets. One is they call it private subnet. Another one is they call it public subnet. Okay. Public subnet has access to the internet. but the private subnet, you see that it does not have access to the internet. So what is happening here is this one is their private subnet that does not go directly to the internet. Only the public subnet is the one that actually goes outside and does the work, or that has access to the outbound. Okay, so what they have here is, you see that they have the RDS databases. One is the master database and the one is the read replica of that. And what they did is they replicated this whole thing into the another availability zone here as well. So what they did is they created an HA capability. They have created high availability. So let's say if this AZ burns down to ground, they still have the application running on the second AZ, or and it keeps serving their customers. Okay, so if I just go to my slide here, thought I have a 3-tier. No, I don't. Okay, so what we're gonna do is we're gonna create 3 subnets in our exercise, in our lab. Subnet 1 we're gonna make public. Subnet 2 and 3 we're gonna make private. Okay, we're gonna put 3 different instances on all 3 subnets, and then we'll try to access subnet 1 from the internet. Since it is a public subnet, we should be able to access that. Then we're going to try to access instances in subnet 2 and 3, which are private subnets, and we'll try to access those. We should not be able to access them directly from the internet. Okay, but how we're going to access them? We're going to connect to the public, and then through the public instance, we're going to try to connect to the instance in the private subnet. Okay, so this will actually validate our logic here, that private instances, they will stay within the private subnet, and they will not have access to the outside world. Okay, all right. So inside the VPC, as we have route tables, then network access control list, or they call it NACL, security group, internet gateway, NAT gateway, and then jump box. What is the purpose of a jump box? Normally in an organization, let's say this is your, sorry, what is happening? Come on. So if I just pick this brush here, is it going to work? Okay. Okay. Normally in an organization, what happens is they have their infrastructure residing within a VPC. They have this instance and other instances. Let's say, they have their database sitting here. And then they have, a couple of application servers, and then they have, a couple of web servers. This top one is, this top one is residing in a public subnet. And then the bottom 2, they are residing in a private subnet. Okay. So in order to grant access to your guys, what organizations normally do is they do not simply just grant access. Let's say your users are sitting here in different computers. So they do not just simply grant access to either of these, environment directly. Okay. What they do is they create a bastion host or a jump box. Okay. What is the purpose of that bastion host or a jump box? Is that you do not, like let's say your developers or your admin staff, they do not get direct access to it, to their infrastructure. But what happened is they connect to the jump box. Okay. And then this jump box has access to any of your, infrastructure here. So this way, the entire infrastructure is not exposed to your internal people as well directly. So let's say if somebody, is doing some malicious thing, it will has to go through, this jump box here. So this jump box could be a Linux machine or Linux instance, or it could be a Windows instance. It depends. Okay, it depends on the organization how they wanted to put it there. So this is how the jump box are being set up. So what happens is, let's say this is my instance here. Let's say these are 3 instances. This is public subnet, this is private, and this is private subnets. Okay, this jump box will be set up such a way that this public machine or public instance, it has 2 interfaces. Okay, one, it has an IP assigned from the public subnet, and another IP assigned from the private subnet, or you call it admin subnet. Okay, and then these machines also you assign the IP from the admin subnet, and only this jump box has this jump box is also, it also has one interface, which is from the admin interface. So once they are in the admin interface, it is the similar thing. Let's say your jump box, and then your machines or your instances are connected through the admin interface. Let's say this is your jump box, you are connected to this jump, and then through the other interface you are able to access any of those instances and provide whatever the task you were asked to do. Okay, I'm gonna pause here. Are you guys with me so far? I know there's it's quite a lot of information here. Any question or anything?
Faisal, is this more like the jump box is playing like a virtual VLANs?
It will be a VLAN, yes. And jump box is just an added layer of security. And I worked with one of the customer. They had like 2 jump boxes. They had one jump box that takes it to the another jump box, and then this second jump box had access to the infrastructure.
And these are all software based, right? Jump
They
box.
are, yeah. Everything is software based here. In the cloud, everything is software based, unless you purchase or you went on a contract with Amazon to go with the the physical servers. Otherwise,
So
everything is all software based.
okay. So this list of where you showing us the list of things here, route table and snackle. Does the knackle sit on the jump box or not?
It does not. It does not.
It does not.
Normally jump box actually sits somewhere here, so that your guys will come in and then connect to your instances.
Okay, thank you. I see the diagram now. I didn't notice that.
Okay.
Thank you.
Sure. Okay. All right, so let me just quickly look into the chat here. Murtaza's question is, jump box different from domain controller? So jump box, Murtaza, jump box is to control the access that over the network, that in the network you define that only this subnet has access to, let's say, this many machines here. Okay, but the purpose of domain controller is kind of different, in this aspect or in this context here. So jump box is normally it actually creates another layer of isolation on the network for the other guys not to directly connect to your infrastructure or to your instances, but go through that one more gatekeeper, which is called jump box. And it's not mandatory to have a jump box. I have seen customers, they have no deployments on jump box. I have seen customers, they have deployment with jump box. And I have seen one that was a state client. They had like 2 jump boxes. You have to go through those 2 hops to connect to that to the infrastructure. Okay. I'm going to start from the inside out. Okay. So here, what we have an instance.
Faisal, real quick. I'm
Sure.
sorry again. Why would you need 2 jump boxes? What's the purpose?
To add another layer of security at the network layer. So just show you here. See that here in this diagram, if I do not have a jump box, my guys, they are in the office. Let's say they are connecting from the office or connecting through a VPN. They have access. They have direct access to to these servers or the instances. Okay. But let's say if one of those machines get compromised, that means the entire thing they will have the access to. But if I have a jump box, if my machine gets compromised, it will just take me up to the jump box. And if I do not have the credentials, the rest of the infrastructure is still intact and is not attacked by the malicious user. That's one thing. Second thing is, there are customers. It depends on how they wanted to deploy that. There are customers I have seen that they have certain tools already installed there on the jump box, so you do not have to install it on your local laptops. So from your laptop, you just go in there, and then you have access to all those tools. Let's say let's say Wireshark is one example, for example, for the lack of better example here. Or let's say you have MySQL. What was that called? MySQL Workbench, or Putty tool, or WinSCP for SCP purposes or whatever and whatnot. So within that jump tool you have, or jump box, you have all those tools installed, instead of, let's say, installing individually on your resources or their laptops.
Oh, okay, that makes perfect sense.
Okay, sure.
Thank you.
Sure. Alrighty. Okay. So I'm going to start from the inside out. You have the instances. Those instances are set up or configured to work on that specific subnet. Okay. Let me, before I start on that. So in that VPC, you provide remember the big block of ice, or let's say you have that bigger chunk or bigger subnet that was provided to you. So you configure that subnet at the boundary of the VPC. So each VPC should have at least one subnet there, and then using that subnet, you carve out accordingly that however many subnets do you need from that bigger block. Say, how many you need for the public subnet, how many you need for the private subnets, or however many instances are going to reside in that private subnet, however many instances are going to reside in the public subnet. So based on that requirement, you carve out that bigger block. So that bigger block actually resides at the VPC layer. So soon as you get into the VPC, you define the bigger block there. Right now, when you log into your AWS console, and if you see there, if you go to any of the availability zones, each AZ will have its own VPC, and each VPC has its own at least one subnet already configured. They are the default subnets what Amazon provides you with a free tier account. Okay, so normally what happens is, when you go work with, not on the free tier, but the actual, working environment, normally whatever is default there, they normally ask you to delete them all, create your own, like they provide you your own subnet, and then you carve it out accordingly, according to the requirement and according to the needs. So one bigger block at the VPC layer, and then here in our example, this bigger block is carved out into 2 subnets. Okay, in this example, they give you /16 subnet, and that subnet is divided into 2 smaller chunks, 10.0.0.0.24 and 10.0.1.0.24. This is also not the right example, but this is also an example of a 2-tier application. Like they have, one in this tier of, like they have one subnet here and another subnet is here. Okay, classical one, you remember, you have 3 tiers. Anyway, so we're gonna come to it. So what happened is /16, it gives you about 65K IP addresses, available ones. They split that up into 2 out of those 65K. They did not create like 2 equal size subnets. They created 2 /24s, like each /24 is 256 IP addresses or host IPs. So you still have, out of those 65K, you have used 512 of combined, like 256 on this one, 256 on this one, so that you have the remainder is still available there. So if you want to create some additional subnets out of it down the road. Okay, so let's say we call this subnet 1 as public subnet, this subnet 2 as a private subnet. Okay, so how they configured is public subnet. When they configure the public subnet, it asks you, when you set it up, it asks you, do you want it to assign the public IP to this subnet? So for the public subnet, go ahead and do that, because here in our case, we're going to be putting our web servers here, okay, which are exposed to the outside world or exposed to the internet. Okay, here in this case, we do not assign any public IP to it. It's just going to be only the IPs assigned from this subnet, which we call it a private IP. Okay, now here you are seeing that there are 2 individual security groups they have created here. Okay, let's just assume that this is our app server and this is our database instance. Okay, so what we're gonna do is this security group, we're gonna just assign whatever. Let's say this is our Linux instance, so we just grant the port 22 or SSH access to this instance. And here, this is our database only, so we just grant only, let's say we have MySQL running under the RDS. So, we just grant the MySQL access, which is the port is 3306. Okay, so we grant this access here. Okay, now what is happening is, so this security group, let's say, this is our, let's say all of our web servers are running Linux. So they are just web servers, and we need Linux access to it as well. So we're going to enable port 80 for the web service and port 22 for our Linux access. Okay, so that's how we're going to configure here, and that's how we're going to configure here. Scrolling up here, we have a NACL or network access control list. How it goes is NACL, not gonna go in detail. So NACL is every access is denied until you explicitly allow it there. Okay, so NACL is the layer. It actually denies everything unless you poke a hole that only this is allowed, otherwise rest is all all the access is disabled. Okay, and we're gonna see once we go into the console, look into that in further details. And then on top of it, we have the route table. What is route table telling me? Route table telling me that this subnet is part of this VPC. It has access to either outside or access to this this private subnet. So that's how we, that's what we define in the route table. So route tables are defined that packet is being routed, from one subnet to the other subnet. Is that allowed or not? Or one subnet to the outside world, is it allowed or not allowed? That's what we define in the route tables. And then we have the router on top of it, and then we have the internet gateway. So internet gateway is normally, let me just show you. So in this example, internet gateway is normally, say, this is our public subnet. So we configure internet gateway to connect to this subnet only. We do not grant internet access to this subnet. So that's why we do not connect the internet gateway to the private subnet here. Okay. Private subnet will not go, or private subnet packets will only go to the public subnet, but they will not go through the internet gateway to the outside. So we do not assign the internet gateway to the private subnets. Okay. Public subnets, since they are going outside and people are coming from outside to, to that subnet. So that's why we assign the internet gateway to them. Are you guys clear on this approach here? Are you guys with me so far? I know that this is kind of a maybe too much information here. Okay. All right. So what we do is we assign the internet gateway to the public subnet, not to the private subnet. Okay. All right. And then there is there's another component here, which is called NAT gateway. NAT gateway is normally used for the, let's say, your machines here or your instances here in the private subnet. They wanted to access outside, but not the outside wanted to access them. Okay. If they have something to do to go outside, as an example, you need something like your Linux instances, they go outside to fetch their packages to update themselves, or your Windows machines, they go outside to get the packages to get updated. Or let's say there is something, let's say you have to download something, so or something that needs to be configured and it is not available, so you want to go outside and get that downloaded. So for that purpose we have the NAT gateway. But NAT gateway is not directly attached to your public subnet, private subnet. NAT gateway also gets assigned to your public subnet, and in the configuration of your private subnet, you tell them, hey, if you want to go outside, go use this NAT gateway, and then that NAT gateway actually takes your traffic outside to the internet. Okay, so this is slide 27. Let me just quickly go up and show you guys the example of NAT, what we did yesterday. Come on. You see that all my machines inside, they are in the private subnet. Okay. They are not in the non-routable or the private subnet. So if they want to go outside, they have to go through the NAT router, or here in our case, they have to go through the NAT gateway. The purpose of NAT gateway is to hide the identity of the machines or the instances which are running behind it. So NAT works as a proxy, like on the behalf of, okay. So all those instances which are running inside, I don't want them to be exposed to the outside world, but I want, but there is some requirement for these instances to, go and access the outside world, to access something. So for that case, we create the net gateway, and that actually preserves the identity of those machines, but get the work done. Okay, so if I'm just gonna quickly go to slide 27 here. So are you guys clear on the purpose of all these here? You're gonna get more clarity once we're gonna do the lab on those. This will be a very interesting one for you guys. Okay. All right, so next one is I'm not gonna go into the elastic load balancers at this time. I'm gonna pause here and let me ask you: are you guys clear on this, or is there anything you want me to provide you any clarity on, or any questions so far?
One question.
Sorry, can you repeat your question, please?
Yeah, one question regarding for nobody can enter and access the machines, right?
You kind of broke up for me. Can you repeat your question again? Sorry.
No problem. So what I understand from net gateway, that nobody from outside, from the internet, can access my machine or server, right?
Correct. Exactly. My private machines, they can go outside using that, but no one from the outside be able to connect to them internally.
Yeah. So this can be reached through a security group as well.
Your machines are gonna go outside through the security group. If inside the security group, if I do not have that outbound rule configured, the packet will just stop at the security group. So I will have to configure that, that security group to have the packet not going to the 000 or to the internet, but it's gonna go to my net gateway. So I'm gonna configure the security group that it is gonna go through the net gateway to the outside.
Okay.
So normally, how we configure the security group is the outbound one is custom 000, like everything just going to the outside. Yeah.
Okay.
Yeah.
Okay. Thank you.
Yeah, sure. So we have a gatekeeper at every layer, and there was a question by Asr we already have a list in security group. Then why do we need ACL? And yeah, Komelva is right. So it is for an added layer of insurance policy that I want to secure that. So if there's a breach happen, it will stop at the NACL. If there's a breach happen and NACL got compromised, still we have the security group. So those layers, they actually provide additional layer of security. To the key thing is to secure our infrastructure, and the very most important piece is to secure our data, which is our database, which should be at the very innermost layer. Okay. Alrighty. So I'm gonna quickly go over the remainder of the slides.
Faisal bhai, one question if you go back.
Sure. Yes.
I was just thinking these NACLs are defined at the router level, and the router act as a NAT as well. Is this like my assumption correct, or?
No, not in this case here.
Okay.
Router is a different component here, and NACL is a different component here. Okay. And the NAT gateway is another component here.
Okay.
Yeah. All right, so next one is load balancing. This is the capability of cloud. Amazon calls it ELB, or elastic load balancers. Okay, there are 3 different types. I think the classic one is deprecated now. 2 major ones you might want to remember: application load balancer, or application LB, and the network LB or NLB. Okay, just remember, application is layer 7, network is layer 3. Okay, so they offer 2 different types of the load balancers. The purpose of the load balancer is, let's say I have an application. Let me see if I could find. Okay, so here in this diagram, so you see that don't worry about this route 53. Here in this example, that you have the load balancer, and I have multiple web servers running, the purpose of the load balancer is, as the name suggests, to balances the load. Okay, there are a couple of different algorithms that run underneath those load balancers. So we can have the load balancer residing at the application layer or at the network layer, whatever layer I wanted to set it up. Common use case is the application layer. So let's say I have this many web servers running, okay, and then I have the load balancer running on top. Load balancer is connected to those. So based on the algorithm, let's say, and this is connected to the internet. So if a user try to access my web server here, or this is web server, so these are all our web servers. So if a user here try to access my site, let's say my site is, let's say, example.com. So it's going to come in over the internet and it's going to hit my load balancer first, and then load balancer will decide based on the algorithm which I have configured, either whichever the web server which is currently available, based on that algorithm it will send in the request, and then get the request output, and then send it back to the end user. Same thing. Okay, so I have behind the web server, let's say I have only one application server running, and I have, let's say, two databases running. Okay, one is the let's say production, and the other one is the read replica of that. Okay, so web server is gonna go to the they all web servers are connected to my application servers, and then that application server is connected to the, it's just a very basic architecture I'm just telling you guys. And then this application server is connected to the database here. So no matter what web server available, load balancer is going to come in, connect to that, send the request to it, and then that is going to fulfill the request, push it back to the load balancer, and then load balancer send it back to the end user. Okay, so two major types, application layer and the network layer. Okay, and that's the main purpose of the load balancer is to balance out the load, or to distribute the load among however many instances I have running underneath it. Okay, so let's say load balancer is we provided information that there are 4 instances running underneath it, and one of the instance, let's say it crashed, or something happened to it. Load balancer based on the algorithm finds out that this instance number 4 is crashed, or instance number 4 is not acting right. So now any new request come in, it will have the list of these 3. So it will just put in send in the request to these 3 until we have this 4th one up and running, and then that will go back into the infrastructure, and load balancer LB will have the list or will have the updated list that instead of 3 now we have the 4th one, so it will start utilizing that as well. Okay, and there's a seamless integration with all those AWS services, ECS or EC2 or CloudWatch or whatever and whatnot. Okay, next item is auto scaling. Okay, this is another feature of the elasticity of the cloud. Okay, so auto scaling is, let's say I have 2 instances running. Okay, and then based on the requirement I define, let's say if my load on my CPU, let's say if it soon as it goes above 75%, churn out 1 more instance for me. Okay, so soon as the load, let's say if I set up the policy for the load, or soon as I set up the policy, let's say if the network traffic goes up to, let's say this much, then churn out this many instances for me. Okay, so I have the minimum capacity or minimum size I have set up. Okay, and I have the scale out capacity already defined. So what's going to happen is I'm going to keep on running with my 2 instances. let's say these two are my web servers. I'm going to keep running with these two instances. Soon as the criteria meets, let's say the CPU increases or anything else, or whatever the criteria I have, let's say, the web server load is increased, let's say to above 90%, then it is going to churn out 2 more instances for me. So now, instead of, initially, which I started with the 2 instances, now I have 4 instances. So this was my minimum size. Let's say let's say 1 is my minimum size, 2 is my desired capacity. Okay. And then this is my maximum size. So maximum, I'm going to go to the 4 instances. As an example, let's say I am running an e-commerce business. Rest of the year, my business goes smooth. And soon as I hit the Christmas time, the hits on my website, it turns into, like, let's say 4 times, or let's say 10 times. Okay. So let's say right now I have 20 web servers running. So I set the capacity. So soon as the, like during the Christmas, soon as the Christmas time starts, and I feel that, soon as the time starts, my load on my web servers, it just, goes like tenfold. So I set up the policy, the CloudWatch policy. What it does is, my web server load, soon as it goes above, let's say 90%, churn out 2 more. And if it remains, let's say 90%, churn out 2 more after, let's say 1 hour or after 3 hours, and keep doing it until I have my load goes up to 75%. Okay. So once I set this policy, so soon as, load start increasing, it will keep churning out. It's not going to churn out like all 500 or all 20 instances altogether, but it's going to go with, it's going to increase it gradually, so that, I do not incur charges like, for an entire bulk, to be, to be powered up right there. Okay. So this way, what's going to happen is my capacity is going to increase gradually. And soon as my Christmas time is over, I set up the policy. Soon as my load is down from, let's say 75 to, let's say 50%, then start cutting down 2 machines or 2 instances at a time, and take me to my minimum capacity or minimum instance size, which is, let's say 10 servers. Okay. So from 100 servers, take it down to 10 servers. Okay. So this way, what's going to happen is, my load is going to increase gradually. Soon as my load or my hits on my website are increasing gradually, my this auto scaling is churning out instances gradually. And soon as the load starts decreasing gradually, it will start, decreasing as well. So this is the elasticity, of the cloud. If it is not configured correctly, so what's going to happen is, let's say I set up, I'm a rookie and I set it up. Soon as the load hits 80%, churn out 20 more, or churn out 40 more. Okay. So what's going to happen is, cloud is going to churn out, like, AWS, they're going to churn out, but I'm going to start, incurring the charges. So that's where, this whole capacity planning comes in picture, that, hey, you know what, go as gradual as possible based on, whatever the previous load, we have seen in the past. Okay. So, but let's say I have an application, but I have a steady load going even during the Christmas time, Thanksgiving time, Eid time, whatever time, the load is, gradual there, nothing's happening, but I still have that configured just to be on the safe side. Let's say there's a new product launched, and I just got the exclusive right of that product. So people will start hitting my site, like crazy. So in order to accommodate that, I have that insurance policy that, if anything happens, churn out like, this many based on, my requirement. So what happens is, you see this here, these dotted ones here. So these dotted ones, they are not powered on. They're just instances are just there. They were not even configured. They are configured, but they were just sitting there. Okay. So what is going to happen is soon as I hit the load, these will powered up. So as long as they are in the dotted state or they are, powered down, I am not incurring any charges. But soon as I, have them powered up, then I will, start incurring the charges. Are you guys clear on this concept here? So SOSV, if you mean inbound or outbound means like scale out or scale down, yes, it works in both ways. So once the requirement is down, then it will scale down, and once the requirement is increasing or keep on increasing, it will increase. But it's not gonna just keep going. You will have to provide some finite number. It does not go infinite. So you have to provide some finite number. Let's say my current infrastructure of web servers is like say I have 10 web servers, and I said that increase it up to 20. So I have to provide some finite number there. Okay.
So does that mean we define ranges? Like if CPU utilization is 90%, turn out 20, and if utilization is 75, turn off 2.
Yes.
Okay.
Yes.
Faisal bhai, if you could just make a note, remind them about the difference between the auto scaling versus load balancing.
Okay. Okay. So
I know you have not covered the load balancing yet, but
I did cover the load balancing part. ELB I did cover here.
Okay, got
Yes.
it.
So load balancing works on existing infrastructure. Okay. Whatever my existing instance is running as a web server, load balancer works on it. Auto scaling, on the other hand, regardless of my existing infrastructure, if the criteria is met, it will start churning out more instances, or it will start shutting down additional instances. So auto scaling, what it does is based on the criteria which is set, it will increase the number of instances or decrease the number of instances. But load balancing on the other hand is just, it works as an umbrella, and then underneath that umbrella I have like let's say 20 web servers running. So instead of hitting only one web server, sending all the requests to that one web server, and then rest of the web servers are sitting there, just like it normally happens on the on the college projects, that one guy is doing the entire work, the rest of the guys are just sitting there for the credit, to take the credit. But here in this case, so load balancer has the algorithm that it does not hit only one web server, it distributes even out among the different instances. Okay. And once we go into the console, and we'll find out that what are those algorithms which Amazon is currently offering.
Faisal bhai.
Yes, sir.
So when you do the auto scaling, does the load balancer then reset to add those auto scaled machines as well?
Yes. So auto scaling gets connected with there's a connection with the load balancer. So load balancer finds out, hey, you know what, I was running I had like 5 instances underneath me, now I have 50. What I'm going to do, so I'm going to add them all up. So auto scaling informs LB that, hey, you know what, you had this much, now this many extra are added there.
So some kind of DHCP service is running somewhere, right? When these get
not
auto
the DHCP, not the DHCP. DHCP is a different concept.
Correct.
Yeah. DHCP
Yeah, I mean,
is like you have the pool there, and then your machine is going and getting the IP address.
Right. Well, yeah. So when these get auto scaled, these are actual machines, right? I mean, these are instances. So they need to have some kind of an IP
correct
assigned to them.
So, yeah, exactly.
So where do they get those IPs?
Right. So when we go into the console, when we go do this lab, very interesting one. So once we go do this lab, you will see, hey, how auto scaling is informing load balancer, or how load balancing is finding out that which instance is there or which is removed, from the umbrella underneath me.
Okay.
Okay. So as you know, what I defined, so telling you the same thing, when you have to define when to scale out and when to scale in, and then, using the metrics collected by the CloudWatch, when to, drive the scaling, go up or go down. Okay. All right. And it's free service. Okay. Um, Similar thing here, just, another, piece of diagram here. Okay. Do you want me to cover the DNS resolution today, or do you want me to hold off for tomorrow's class, cover DNS, and then, do all those labs tomorrow? It's already 8:01.
Yeah, I'd say we do it tomorrow.
Yeah.
Information overload for a lot of us.
I totally understand. Totally
Wait a
understand.
minute, we have class tomorrow?
I am planning to, tomorrow's office hours, we're gonna run that as a class tomorrow. Because there's a whole lot to cover in the lab, because we have tons and tons of labs for for tomorrow. Let me just show you guys. We have to do a lab on database service. We have to do a lab on entire VPC. Also, ELB and auto scaling, we're gonna do the labs as well. So tomorrow I'm gonna be sending out the meeting invite to you guys. It probably be our Google Meet. I'm not sure if Kumail Bhai is available, but I don't want to bug him. He's already been with us for for half of the week. But anyways, so I'll set up for the Google Meet, and we'll send send you guys the invite. Okay, so it will be 6 to 8 p.m. Chicago time tomorrow, which is Friday.
That would be recorded as well, right?
So are you planning
Yeah, Faisal Bhai, yes, I'll be there. Yeah,
I'll record this. I did record the previous session, so I was just asking Hassan, are you planning to skip that, Hassan?
Yeah,
I was going to say Faisal Bhai, buy Kumail by a Starbucks or something.
I have some engagements tomorrow. That's why I was asking.
Yeah. So Kumail Bhai cigar is on me tomorrow. I know Kumail Bhai does not smoke cigars, so.
No, we'll get together, inshallah. So Faisal Bhai, I'll share the link with you shortly.
Oh, perfect, Kumail Bhai. Thank you very much.
Yeah.
Alrighty. So guys, as soon as I have the link, I'll send it to you guys. I know there's a whole lot of information yesterday and today. Please come with questions tomorrow. Review this. Go through the both the lectures. Go through the slide deck, and because I want you guys to be comfortable with all these terminologies and all these the entire network area. So I'm here to answer any question, but yes, please go through all those, and make sure you have at least one question for me tomorrow. Otherwise, I am feeling that you guys either understanding everything or something else is going on. Okay.
Or ask me privately. I will help you with asking a question.
Yeah, sure. Yeah. Okay.
Faisal, this is Mujahid again.
Yes, sir.
Looks like you're devoting a lot of time to networking and all of this stuff. What is the percentage of questions on the quiz pertaining to networking?
See, network questions are not that very much, but the reason is network is pretty much all over AWS. You do not have the base understanding of networks or networking. You will be struggling with even EC2 instances or databases or whatever and whatnot. So that's why I put an extra focus on the network side.
Thank you, sir. I appreciate it on behalf of everyone.
Thank you very much.
Without network, you cannot configure anything within AWS, I guess.
Yeah, exactly. I mean, you can configure things, but you will not be able to access them.
Yeah, exactly.
And, yeah.
Faisal bhai, I had a question.
Sure.
I think you've heard about the recent breaches that that a lot of companies have had in the past. Home Depot losing their credit cards, Target. Other companies also, they're targeting the POS terminals, having malware on it. Where do these like POS terminal devices on the network reside? If you were to like design most of these things, I mean, the weaknesses were sometimes not hard to decipher if they're on the network. In those kind of cases, but do you have an incident that weaknesses in the network kind of can be exposed?
So to be honest with you, I mean, I have not worked on the POSs. If the POS is, let's say you have the internet connection in your, let's say at your business, then connect the POS through the VPN, not just exposing it directly, or get a public IP address, static IP address to that, so that that POS only gets connected to the infrastructure, not from not through the the open internet. That's that's two of the areas which I could think of. I have not worked on POSs, so I'm not sure. I mean, how are they connecting? Are they connecting through your wireless network, or through your direct phone lines or whatever and whatnot? So based on that, so try to minimize the connectivity point as much as possible. Even at your office, let's say it is going through your router, your office router, or let's say your business router. So configure VPN there, so that all the communication that is going as an encrypted one, or configure a VPN tunnel from your from your business to your data center or to your cloud connectivity. So this way, one thing is it will be a point to point, and second thing is it will be all encrypted.
Got it. So, I mean, besides this, I mean, there's other also IoT devices that sometimes companies use. Is there a separate segregated area that you kind of put all these devices, which are not PCs, servers, personal machines?
Yes.
Separate.
So there is a Amazon offers one service for IoT.
Azure also does that. Microsoft has a POC module that connects with their Dynamics ERP.
Right.
If companies implement it correctly, if they have the right, the POC sitting in the private network as opposed to the public network, that's a safer route. Bad designers exposes everything on the internet. There are tons of articles out there where people exposed, private data services on the internet directly. So shouldn't be there. 90%, 99% of the these hacks or data compromise issues is a human error.
They miss secluding all of these devices. I think based on the Home Depot story, I think they gave one of the refrigerating companies extra access, and
exactly.
Remember, the weakest link in your security is your end user. So no matter how robust, how best of the best you have infrastructure set up, if your users are not aware of how to utilize that service, it's just useless there. There was a breach, and I forgot the name of the company. It was kind of a nightmare for them, because they left everything unencrypted on their S3 bucket that has the PII data of their customers. So
Capital One.
Yeah, I guess Capital One. Yeah. So these type of embarrassments, they may have the best in the industry, CISO and all the security team, and invested heavily on the security gear. But you're making these type of rookie mistakes. You're just opening it up. There was a couple of years back, there was not the breach, but Facebook eventually they accepted it. they denied it initially that their critical passwords were in a text file sitting on one of the computer.
I bet you if you take a vote right now, there are several of you who have like some cheat sheets sitting
Yes.
on computers with all the passwords.
Yes.
And there is a high probability 80% of you are probably using the same password in 5 different places.
Yes. Let me stop recording. I mean, let me tell you one good story here. Let me tell you one good story here.
Kamal is hacking our computers or what?